So, hello everyone, and welcome to this session number 6 Ask AuxEn Anything that we do every week. And this is the sixth such session that we are conducting. So, in this, we try to answer the questions, queries that are raised by structural engineers, and those queries can be related to some concept related to RCC or steel design, or any project related query, or any challenge that they might be facing in the construction on their site. So let us begin with today's questions quickly. So first question is being asked by, or let me just take few questions that were asked on email first. So there were a few questions asked by Engineer Tosh, and he is joining from Raipur. So Engineer Tosh Agrawal is asking a few questions. I think let me take those questions first, and then we will start or continue with these questions in the Google form. So first question he is asking is related to, please explain how the hollow section truss is to be connected with column. Please discuss various possibilities. So he has shared one image over here. I'll put that image and we will start our discussion. So he has given this image. Let me share it on the screen. And yeah, so this is his first question, that he has a hollow section truss. He's asking how it can be connected to the column. So there are multiple options, multiple arrangements possible. One of the arrangements can be, for example, you have a hollow section truss like this. Okay, I hope you are able to see the photo. I mean, image that I'm trying to draw. So one of the options can be like this, where you, and let's say this is my truss. So one of the options can be this, that you have your column over here, and this is the way in which you are connecting. So that means you will develop a joint over here between the hollow section and column, and other joint you will develop over here between the hollow section and the column. So this can be one of the possible options in which you would join this hollow section truss with your column. Other possibility can be that you may continue the same arrangement like the hollow section truss below also, like this can be another possibility. Okay, so for example, you continue this kind of a system below also in the column. So column is also here built up, let's say. Okay, so column was built up and your hollow section is also built up. This is another possibility that you can have. Okay, another possibility could be that you have your hollow section truss, and so this is my hollow section truss. Now you may put a plate over here, you may put some stiffener arrangement, and you could have your regular column below this. And just like a normal system, you could do with this case also. Although that will not be very popular, because in this case there will be a lot of horizontal thrust generated due to the shape of this truss. So this might not be a very effective solution for it, but still you can do it this way, that you may add some stiffener plates over here, and then have a plate welded to the bottom of this truss, and then have a regular column, and on column top there will be another plate, and then those two plates can be connected. So this can be another possible alternate solution. So there can be multiple ways in which you can connect this hollow section truss with your column. So not a single solution, multiple options possible. All right. Okay. So this was his first question that he had asked. His next question is, and I am going to copy his question from the email. So he had sent his queries on the email. I'll just copy it from there. So where is it? Yeah. His next question is, in conventional steel building with stepped columns, we provide bracings in roof leg. Yeah. So his next question is this. He's saying in conventional steel building with stepped columns, we provide bracing in roof leg and bottom column as well as in crane column. Okay, that is his question. Do we provide bracing in roof leg and bottom? See, where to provide bracing, where not to provide bracing, that will depend on your overall lateral stability. His basic question is let's say I have a roof leg over here, and at bottom I have a stepped column, and I may require that stepped column because let's say there is a situation of crane, whatever, and this is let's say some lacing system. So stepped column is wider, and then I have this roof leg, and then that roof leg is supporting some roof truss or portal or whatever there is. So he's saying you may have to provide bracings over here because there might be a gantry girder which may be supporting some crane bracket. So maybe at the stepped column you are providing some in this column, main column, you are providing some bracing arrangement. So in the roof leg, he is asking, do we need to provide bracing arrangement? Yes, no. So see, the bracing arrangement for this below bottom column, it is required because you may have to take the lateral and longitudinal thrusts from this crane, whatever lateral and longitudinal thrust across and transverse responses and along responses that are generated due to this crane. To take those thrusts, you may have to provide bracings in this main column. In this roof leg, we might have to provide bracings because we want to stabilize this system, which consists of your roof and this roof leg column. So the need for providing bracings may be different. In the roof leg, you may want to provide bracings because you want to provide lateral stability to this system. And in the crane portion, in the bottom column portion, you may want to provide bracings because you want to take the lateral thrusts and longitudinal thrusts coming from the crane. So reasons might be different, but you may have to do that. You may have to provide bracings. Okay. Yeah. Then his next question is more of a general query that many people have, and I'll just put it over here. So he's saying vertical bracing in PEB shed need to be connected near outer flange or in web middle. Okay, so I guess his question is, let's say I have a column over here. I'm drawing the elevation, front elevation. Let's say this is my column, 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 and imagine this to be your front elevation. And let's say I have a bracing provided over here. Okay. Now if I see the sectional view of this, let me try to draw a sectional view. So in this sectional view, let's imagine that this was an I-shaped column. So this is my I-shaped column. This is the flange of that column. This is the web. Now logic says the purpose of this lateral bracing Okay, not let's not take the case of lateral bracing. Imagine that instead of this cross bracing, there was a member that we had, let's say guts, or let's say any member that we have added to support this column for the lateral torsional buckling, let's say. Okay. So now his question is that in this section AA, I should connect this member which I want to provide to support lateral torsional buckling. Should I connect it to my compression flange? Imagine that compression flange was on this side. Or should I connect it to my tension flange? Or should I connect it to my web? That is what his question is. So any member from which you are going to take the effect of lateral torsional buckling, should you connect it to web? Should you connect it to compression flange? Or you should you connect it to tension flange? That is what is question. So see, logic says that because you want to restrain or provide support to compression flange, so any element or any member where you are intending that it will provide effective lateral support, it should be as near as possible to the compression flange. Okay. Now sometimes that might not be possible. So for example, if I show you the plan view of this same column, imagine I wanted to show you this sectional view, BB. So what happens many times that, let's say this is my column flange, this is my web, this is my column flange. So ideally, and let's say this is my compression flange, this is my tension flange, this is my web. So now ideally I would wanted to attach my member as close as possible to compression flange, but due to many reasons, let's say it's not possible. So I may have to put my member over here to the web. But now if it is to the web, it's really not holding the compression flange. So then I introduce some elements like this. It may be called as a flange bracing. So we will introduce this type of an element, okay, to support the compression flange. Sometimes in cases of girts, what we do that girts are usually on the outer face. So girt is like this. As long as the compression flange and girts are connected together, it's fine. But let's say the compression flange was on the reverse side. Reverse side means the opposite side to which girt was connected. Now, in such a case, again, we may provide some element like this, which is called as the flange bracing. Is this clear? So, concept says that your member should be as close as possible to the compression flange. If not, we have to come up with some system which does it. Then he's saying if not at center of web, then will the eccentricity caused be any problem in resisting lateral loads? So he's saying that if you are connecting it like this, which is eccentric to the web, or if you are connecting any other position but not at the center, will it cause eccentricity? See, it will cause, but please remember that it is also being sort of carried forward to the other members also. So if whatever push pull is happening, that is also happening on the other side. So it's rare that this situation or this will cause any eccentricity or plant torsion. And also remember that for that we also usually have a bracing like system also. So that bracing like system will take care of any plant torsion or any torsional effects that might come due to this eccentricity. Okay. So usually we don't think about this eccentricity. There are enough bracings that we do provide, which should take care of this. Okay. Okay. So this was what he was asking. If people have any comments, they can put it in the live comment section also. Then we go to his next question. His next question is he has put this image. I think it is from the Steel Handbook. And what is he asking? I'll just put that image first. And then what is his question? Show how this PB roof monitor is connected to rafter and how this whole system is formed. I think the image is quite clear. Just a minute. So his question is this. So his question is how this PV roof monitor is connected to rafter and how this whole system is formed. Please explain. So I think it's quite self-explanatory. This image itself looks quite self-explanatory. Number one thing, why do we need to provide such a thing? Why is this roof monitor being provided? I mean, you had a roof over here, perfectly fine. Now, why do you need to provide this system? So usually this system is provided because you want some ventilation, air ventilation to occur. Okay. So what happens is that you create a gap over here. This is a gap in the sheeting. That means so your hot air, let's say if it rises above, it can escape from here, escape out. So hot air has a tendency to rise up. And if you see in your overall PV shed, and this is my roof monitor. So if you have provided this, so a natural draft gets created, and the hot air that rises above has a place to exit from. Okay. And then you can also add, let's say, lowers at the bottom. So then cool air which is at the lower altitudes can enter into the shed. That cool air, when it gets hot, it can rise up and then get exited from here. So it's a natural draft, pressure draft that is created, and therefore these types of roof monitors may sometimes be provided. So this is a natural draft. Natural draft means a natural pressure difference you are creating. What is a forced? What is an example of a forced draft? What can be an example of forced draft? So forced draft would be, let's say, where you have to install turbofans, or where you have to install uh, yeah, mainly turbofans can be example of uh, forced draft. You're forcing the air to come out. This is an example of natural draft, where you are allowing the air currents to just pass through naturally. Okay. So that is the purpose. Now, having understood this purpose, how do you provide it? So provision is simple. You will just add a so your sheeting for this roof will come only till here. Your sheeting stops here. This sheeting stops here, and then the next set of sheeting is provided over here. So to support this, you have taken a post, column post, or call it as the roof monitor post. Usually, it can be a normal pin connection or a hinge like, I'm saying hinge like connection that you create over here. Okay. So if you can see, the web of this roof monitor is connected, the web of this roof monitor is connected to the flange of this rafter through cleats. So this is the cleat connection that they are providing, simple connection. And then this post, or not post, this, call it this as the post, this can be a roof monitor rafter. So then this connection can be created. Okay. So I think here what they're doing, I'm not sure what they're doing over here. How have they connected? I don't quite understand how they are. Acha, I think I'm not sure how they are connecting this, but you can have normal cleat connections over here made. It's not a big deal. Okay. So in this manner, you can create this assembly. So this is called as a roof monitor, used for used to create natural drafts in your sheds. Okay. All right. So I think these were his questions that he had asked. So now we move to questions on the Google form. So let me just take them, and I'll share my screen. Yes. So Mr. Vijay Makwana, he's from Ahmedabad. He's asking, uh, What he asking? We can take beam column capacity in ETABS as no. No. So beam column capacity, to understand beam column capacity, please go through IS 13920. They have in depth explained the conditions under which you have to consider the beam column capacity ratio. So if you are in zone 3, 4, 5, as per the current IS 1893, you have to consider the beam column capacity ratio. Beam column capacity ratio is only allowed for you to be ignored at the roof levels, that too if you have a structure which is 4 stories or tall. So beam column capacity ratio you cannot ignore as per IS 13920. It has to be taken, and it was introduced in the year 2016. Before that, your 1993 version of 13920, 131, what is the number? 13920, sorry. Before that, your 13920 2000, sorry, 13920 1993 did not have this provision. They did not have this requirement. But now, this code quite clearly says that for zone 3, 4, 5, and now after the revision is introduced, maybe zone 6 also. So you have to take beam column capacity ratio and ensure that the moment carrying capacity of column is 1.4 times the moment carrying capacity of beams. So you cannot ignore, you cannot put no over here. There's only one provision, that if your building is more than 4 stories tall, then at the roof level you may not do this check. So at the roof level, it is allowed to not check the BC ratio. Okay, that is also for stories more than 4 stories tall. Otherwise, you have to check, and those processes are clearly given in 13920. You may go through them. So in ETABS, his question is, should we put no over there in the design preferences when we are uh, doing concrete design? Answer is, you cannot put a no over there. You have to consider beam column capacity ratio check as per the 13920. Okay, good. So this was his question. Then next question is being asked by, let me just share the screen. So next question is being asked by Mohammad Saif Ahmed Chaudhary. He's joining from Guwahati. He's a working professional. He's asking, can you tell us about the load combinations? Can you tell us about the load combinations we can use in the underground tank when we have multi-compartment tanks? Okay, so in case of multi-compartment tanks, if you have such a scenario with you, then first you need to understand that what is going to be the process, that is, what is the process diagram, or what is going to be the process flow. By process flow, I mean, let me just draw a multi-compartment tank first. I'm drawing I'm drawing a plan view. So let's say this was this type of multi-compartment tank. Okay, are you able to see this? In our liquid retaining structures course, we have done these types of cases in great detail. Yeah. So can you see this multi-compartment tank? This is the plan view, of course. So first of all, you need to understand the process flow. Process flow means that where is the liquid going to enter, from where it is going to discharge, all those things. Let us say that this is a multi-compartment tank and the process flow is such that first the tank 1 fills up. Okay, just understand. Then then tank 2 fills up, and after tank 2, let's say all these 3 tanks will fill together. Do you understand what I'm trying to say? How can that be achieved? So it's easy to achieve that. So maybe from 1 to 2, I have a pipe which is at the higher elevation. Higher elevation means if I draw a section, let's say this is tank 1, this is tank 2, and the pipe over here is at this level. That means what? That first liquid will fill in this tank 1 till this pipe level, and only after that it will go into the tank 2. Do you agree with this statement? Yeah. And let's say the connecting pipe in this tank 3 and 4 is at the very bottom of the tank. So if the pipe is at the very bottom of the tank, what does it mean? That the tanks 3, 4, and 5 will get filled up together. You get it? So what I mean to say is, first you understand the process flow. Once you understand the process flow, then you will understand which tanks will fill together, which tanks may not never be filled together, which tanks will always be filled together, where do you need to consider part by part filling, and all those things you need to understand first. Okay, there are some situations where one tank fills up first, there are some processes that happen, and then all its liquid will empty into this another tank. So if you understand all these processes, first understand that. So imagine that I have a situation where tank 1 will fill first. After filling of the tank 1, all its liquid will now then go to tank 2. After the tank 2 is filled, then all the liquid will simultaneously fill up 3, 4, and 5. So then how do you need to understand? So when the tank 1 is going to be filled, the water pressure will act like this. Do you understand? So now you may need to make one, let's say, load case. Let's call it as the load case W1, where you will apply the water pressures on this tank first. Then you will create another load case. So this goes with W1. Then you will create another load case. Let's call it W2. So we have W1. Then you create another load case W2, where only these tanks gets filled up. Okay. So this becomes your W2. Then, as per the process, all the liquid in tank 2, let's say, gets into tank 3, 4, 5, or let's say not all tank, but now there is a possibility that the tank 2 is also filled, and it will slowly discharge its liquid into tank 3, 4, 5, and tank 3, 4, 5 will fill up simultaneously. So now you will have a situation where you will, let's say, create these types of liquid pressures, but then they will be acting simultaneously. So when they act simultaneously, for example, the common wall between 3 and 4, or the common wall between 4 and 5, will it have any significant moments or shears in it? Tell me. If the tanks 3, 4, and 5 are going to be filled simultaneously, will it have any pressures on the common wall? No, because the pressures on the common wall will get balanced out. So in this manner, let's say I have made three different possible load cases. Now these three different possible load cases, and imagine this was an underground tank. So the earth pressure will continue to act in all these cases from outside. So earth pressure is acting from outside. There is no variation in that. So now once I have these three load cases, W1, W2, W3, after exploring all the possibilities, these are the three load cases that we have made. So now we will combine them in the load combinations. Okay, is that clear? So now whatever are your respective load combinations, you combine them in those load combinations, all the three different possible scenarios. So whenever you have multi-compartment tanks, this is the way in which you take it up. I hope that answers your query. So to start with, first understand the process, how those compartments of your multi-compartment tank is going to be filled, and then do this. Okay. All right. So I hope that answers the query. Now we move ahead, and the next question being asked is, where is it? Yeah. So the next question is being asked by Mr. Ketan Mahajan. Uh, he is asking, is there any design procedure for fixing of screws, that is the center to center distance of screws for roof sheet and purlin? So usually that is a, I mean, that the, I'm not very sure about any code for this, but usually your fabricating agency understands that depending on the sheet size, uh, depending on the sheet size, where you want to connect it. Now, usually speaking, if I were to draw a plan view for this, what has happened? Ah, share. Yeah. So if I were to draw a plan view, no, okay, let me draw a sectional view. So this is my purlin, let's say Z purlin, okay, and on this your sheeting is going to be attached like this. So usually all the troughs, this will be connected. That is, I mean, that is quite obvious. So these troughs will be connected. Now in the plan view, if I were to see this, same thing. So this is one purlin in plan view. This is the other purlin in plan view. And then you have your sheeting. This is the corrugated sheeting. So the valleys, wherever there are, they are naturally connected. Each valley will be connected by a bolt, and it this thing will happen on all purlins also. So usually this is the way you will find the sheeting is connected to your purlins, and these are usually called as the self-tapping screws. So these are called as the self-tapping screw. These days nobody uses the J hook or J bolt. J bolt used to, what used to happen, that you used to have this and there would be a J shape which would hold down, which would attach itself to the bottom of the flange of the purlin, and that was called as a J hook or a J bolt. But these days nobody provides J hooks, although J hooks are much more strong. And we have had clients where they had insisted that instead of going for self tapping screws, you provide J hooks or J bolts. So anyway, that this is how your connection between the sheeting and purlin usually happens. His next question is, Acha, by the way, who was asking this question? Wait a minute. Mr. Ketan Mahajan, he is a working professional and he is joining us from Jalgaon, Maharashtra. So he is asking these questions. First question was design procedure for fixing of screws. So design procedure means you have to, need to know the capacity of each bolt. Accordingly, you find out the numbers. I have given you the positions where you can fix these screws. Okay. Okay. His next question is, I'll just copy. Yeah. So in bungalows, he's saying, in many of bungalow projects, I have seen ground beams and plinth beams at different levels. How to analyze them, and does it act as a frame? See, you don't need to model them at different levels. Usually, what you are saying is right, that our usual construction happens in this way, that this is my ground level, and then I will have a raised plinth. So this will be a raised plinth like this, okay, and maybe on the outer periphery you will provide a beam which is slightly above the ground level, otherwise below, and your columns will go like this. And in the inside portion, you may have these beams which are provided near the plinth level like this. So few beams are provided at the plinth level, and few beams on the periphery especially are at the ground level. Okay, so I am calling this as my plinth beam, and these are my ground beams. So on the outer periphery is what you see over here, and this is my plinth height. So do we need to uh, analyze them separate? I mean, how do we analyze? Just your usual process. So in ETABS or in STAT, wherever you are modeling, you just model all these beams, whether it is a ground beam or a plane beam, assuming they were at same level only. For small projects, you don't need to consider their heights at different levels. That's not required in my opinion. You can just analyze them assuming they were at one same level. Okay. Then he is saying how to analyze them and does it act as a frame. So he's saying in some cases what may happen that your secondary beam like this is also there. Now this is not resting on RCC beam, but there was a brickwork that you had cast and it is resting over there. Yeah, that does happen. But why do you want to analyze this as a frame? You don't need to consider any lateral load resistance. See, because this is on the ground or the plinth, anyway the lateral load resistance or any lateral force that is acting at this level, we'll assume it as zero, isn't it? The story shear at this level, story force at this level, sorry, will be zero anyway. So I don't need any lateral system as such, or I don't need any frame system to be created over here to take lateral loads. Gravity loads, this system can also take, it can pass through brick walls, load can be transferred. If you're not very comfortable with brick wall, sometimes we create a small concrete, let's say pedestal sort of a thing over here. So from plinth beam, sorry, from this ground beam, you can take some reinforcements and you can create a small pedestal. And on this pedestal, your secondary beam or this beam can rest. That can be done. Lateral load resistance is not a problem. You just need to ensure that the gravity loads are safely transferred. So I think it's not a big deal as such. Okay. Okay. His next question is it allowed to provide a single pile cap below a column? You may provide single pile cap below a column, but then please remember that if this column has any moment, then this connection, then this pile connection will not be able to resist that moment. So then you need to provide pile caps also. Oh, sorry, pile caps. What I'm saying. You need to provide these beams also, not pile caps. You need to tie them up by providing these beams at pile cap level. So then these beams will help you to take the moment, if any, in this column and help you to safely transfer that moment through axial action rather than movement. So then these beams are needed. If not, then you should provide multi pile pile caps which will be able to resist moment about the axis of the piles. I mean, about that axis where the piles are given spacing, about that axis, they will be able to resist movements. Okay. So then this arrangement shall be provided. If not, you tied, ensure that pile caps are tied properly to each other with beeps. Good. So that were his questions by Mr. Ketan Mahajan. And now we just go quickly to next question that is being asked by Mr. Aftab is asking, he is from Bengaluru, he is an undergraduate or a postgraduate student. How does tension field action develops in plate girder? Uh, how does tension field action develop in plate girder? How are the anchor forces and resultant longitudinal shear resolved? What is the difference when we design end panel using tension field action with single stiffener and double stiffener? So I think it's more of a theoretical question. What I'll suggest him is that you go through the book by Professor N. Subramanian, and I think it's a very good book which will help you to understand this tension field effect. And Sir has explained very well in his book. So just go through the book. In IS 800 2007, I guess the clause number is 8.5. Over there also, they have explained a few things about the tension field theory. You are suggested to go and refer to them also. The basic principle is that, let's say if I have a plate girder like this, all right, and usually in plate girders we have thin webs. So if we have thin webs, there is always chance that this thin web fails under buckling. So then we check as per the, we will check this web for the web buckling effect, and accordingly either we will limit the load or we will provide transfer stiffeners, isn't it? This is the usual process that we do. So this basic calculation is done by what is called as the simple post critical method. What is the name? Simple post critical? No, just a minute, I'm just recalling the name. I think it is called as the simple post critical method. It is given in 8.4.2.2 IS 800 2007, 8.4.2.2. So by simple post critical method we will calculate the web buckling, and either we limit our loads or we provide end stiffeners. Okay, so we provide end stiffeners like this. Now let's say if I provide end stiffeners and I have provided these end stiffeners and I am calculating the web capacity based on the simple post critical method, which involves or which assumes web buckling. Now if I were to increase the load even beyond that, if I were to increase the load even beyond that value, let's assume it a simply supported case just for simplicity. So what will happen if I were to increase the load even beyond the web buckling, and this was a case where I had provided intermediate stiffeners. So now what will happen? This will start acting, or rather, we say that this will start acting as a truss. So in truss, what happens? Suppose this was a simply supported truss. What will happen? So these lines that I'm drawing, they will start acting as which type of chords? Tension chord or compression chord? So these types of chords will start acting as your tension chords. Okay. Yeah. Now these compression chords which were in this direction, they will already, or we will assume that they already have undergone buckling. So these compression chords are already failed under buckling. Okay, so you will see these types of ripples being formed in your plate girder because the compression portion has failed under buckling. But still, even if we were to load this plate girder beyond this, even beyond this state, okay, so we are now calling it as the post yielding state. My web has buckled, the compression cord of the web has buckled, but still if I were to increase the load, what do I see? That my web is still able to take loads. Why? Because now these are acting as my tension cords. So imagine now it has become a truss like system where these are my tension cords, sorry, where these are my tension cords. This becomes my tension cord. This is a case of an N type truss. This becomes my tension flange, and my compression is being resisted by the compression flange at the top and the compression in these stiffeners. Do you understand this much? So this type of tension, this is called as development of a tension field theory, or sorry, this is called as the development of tension field. And even beyond the web buckling, you see web has buckled, but even beyond this, the plate girder as a whole can continue to take even more shear because of this tension field effect. Understood? So this, simply speaking, is called as the tension field effect. So in the tension field effect now, The top chords are taking the compression, the bottom chord is taking the tension, these stiffeners are taking compression, and then this portion of my web is sort of taking the or acting as a tension diagonal. Clear? Now what happens that in so this is my internal panel now. In the internal panel, things are good because you have equilibrium between the forces in the top flange, in the bottom flange, in these stiffeners, and in this diagonal, and in this diagonal. Forces are balanced in the internal panel. But when you come to the outer panels, things become complicated because now what you see, there is this force acting, there is this force acting, and it is sort of an unbalanced situation, isn't it? So now what you have to do, that these stiffeners that you provide at the end, now this end stiffener has to be designed to take this force that you have in the chords. So this stiffener has to act as a beam, imagining that this was the span of that beam and the forces that are being generated in the top and bottom flanges. So this stiffener has to be designed for it. So this is called as designing the stiffener for anchor forces. Okay, this is called as designing the stiffener for the anchor forces. So now if you have a double stiffener system, that means stiffener is on both sides. Then the stiffeners have to be checked. Both the stiffeners have to be checked for taking the bearing loads at the support points and also these anchorage forces. If there is only one stiffener, then it has to take the bearing reaction and also the anchor forces. So basically, this is in short what you can understand as the tension yield, tension field theory or tension field effect. If you want to read more, as I told you, please go to book by Professor N. Subramanian. He has given wonderful explanation about the tension field effect, and also you read the code. I think section 8.5. Okay. Okay. So this was what I just wanted to discuss briefly about the tension field effect. And now, if I go to next set of questions. So Mr. Alek Kotwal is joining from Kathmandu. He is a working professional. Alek Katuwal, sorry. Alek Katuwal is joining from Kathmandu. He is a working professional. He is asking importance of height while designing boundary limits of shear wall. Okay, I think I'll just copy this. And so Mr. Alek is asking importance of height while designing boundary limits of shear wall. So I think what he is asking is that, let's say if I were to draw an elevation of this shear wall, this was the elevation of a shear wall, and these were the different story levels, let's say. And of course, shear wall is continuing through the entire building height. Now, we all know that boundary limits are usually provided when your stress level at the extremes exceeds 0.2 FCK. Yeah. And it has to be continued as per the code till your stress level reduces to 0.15 FCK. So it has to be continued till your stress level reaches to 0.15 FCK. Is that clear? So the simple answer is you need to provide boundary elements throughout the height till which the extreme fiber stress drops below 0.15 FCK. You have to start where the extreme fiber stress exceeds 0.2 FCK, continue it along the height till your extreme fiber stress is less than 0.15 FCK. Okay, is it understood? Yeah. So that is a simple answer that you need to understand. Yeah. And what about this dimension? So we have often discussed about this. You can follow previous sessions where we have discussed how you can find out this dimension of your boundary element. My suggestion, will be to not discontinue boundary element even at 0.15 FCK level. In shear wall, it is always better if you can just continue the boundary element throughout the height of the shear wall. Don't discontinue it at 0.15 FCK. His next question is RITS versus model analysis in ETABS. That is an inappropriate question. His question should have been RITS versus eigenvalue analysis, eigen analysis. Okay. So RITS is also a model analysis. Eigen is also a model analysis. In RITS, it is only the type of mathematical extraction that is done for modes. That means in Eigen you don't have the control on the output that you are getting. Now in RIDS we have a control. So suppose I were to give this command in ETABS that please give me all the modes in X direction which contribute to 80% of mass participation. Understand please. Okay. So this is the sort of command that I have given, or this is the type of extraction I want. I want to extract modes till the time or till the modes where I get my mass participation in X as 80%. Okay. So it will only give me those modes now. And let's say I have capped the limit to 24 modes. Number of modes I have written as 24. So in the first 24 modes itself, ETABS will make sure that it will only give you those outputs, although the time period may be very small for it, but still it will only include those outputs which will ensure that the total mass participation in the X direction is 80%. Do you understand what I'm trying to say? Or suppose you gave this that I want the total mass participation in X as 80 and maybe Y as 90. So please, these are the two conditions. Now under these two conditions, just print out or just give me the modes in the first 24 modes itself that satisfies this condition. So what basically is going to happen, it will disregard or it will not give you all the meaningless modes. It will only give you those modes which together will satisfy these conditions. So basically it helps you with your analysis time. Unnecessary modes which are neither contributing in the mass participation nor they are having any significant contribution otherwise, they will be ignored, and instead of that only the meaningful modes will be given. Meaningful mode means depending on what extraction you want. So this is called as the RITS analysis. So RITS versus eigen, that is the basic meaning of it. Okay. Okay. How to copy load combinations from one model to another? Very easy. Use the interactive database editing options in eTabs. Use the interactive database editing. So go to one model, open it, then go to edit. We have discussed so many times, Mr. Alec, in our previous courses that you have joined. We have discussed this so many times. So go to edit, go to interactive database editing, then under load definition, go to load combinations. Then you will see a table. Copy that table, send it to Excel, then open another model. Again, open the edit interactive database editing. Again, go to load definitions, load combinations, bring that table to Excel. Then from your original model, so let's say your model 1 was there. From model 1, you need to copy to model 2. So open the interactive database editing, take that file to Excel, and again in model 2, open the interactive database editing, take that load combination file to Excel. Let's call it as the Excel file 2. So then you copy whatever you wanted to copy from Excel file 1, paste it in Excel file 2, and then go back to your interactive database editing in model 2 and say to retrieve the table from Excel. So once you retrieve the table from Excel, the modified table will be brought. You apply it to the model, so the changes will then be reflected in your model. Okay. Okay. Then I guess the last question being asked is by Mr. Sandeep. He is joining us from Mumbai. He is a working professional. He is saying at site how a brick wall is constructed on a steel section. Usually, we will just put the brickwork on the ISMB flange. It's quite simple, very straightforward. So, whatever brick wall you want to construct, you can construct just by putting it on top of flange, whatever your ISMB flange is. Uh, just one thing you need to understand. So, let's say this is my ISMB flange. Okay. So, you just put a brick wall on top of this. Only thing you need to understand is that some people, to make a homogeneous and proper joint, you may provide some mesh over here, steel mesh, which is welded to this top flange, and this will help you to integrate your brick wall better. Okay. Otherwise, the process is normal. So this chicken mesh or murga jali, what we call as, you can provide this. Okay. All right. So I think these were the questions on the Google form. Now let us take a few questions from the comments. So Mr. Tosh Agrawal is asking, in both column, in stepped column, we need to provide bracings. I think we have answered this. Mr. Tosh, please refer to the reply we have given. Mr. Magaj is asking, do we need to check crack width for retaining wall resisting only soil pressure? If your soil contains soil water, or if your soil contains any chlorides or sulfates, then you need to check it for the 0.2 mm crack width. Otherwise, if your soil does not contain any soil water, or if there is no harmful chloride, sulfates, nothing, then maybe you can allow crack widths up to 0.3 mm. So this is given in the IS 456. If you read the first section of limit state method, this thing is given. Okay. Then Mr. Magaj is saying, if we have basement and some part of the slab has to be designed for uplift and we have loose soil under it, in this case, what is better and economic option to resist uplift? I think we had answered this question in the last session also. So either you design your slab for uplift, uh, or you try to increase the self weight so that it may be able to counterbalance the uplift, or if you have a loose soil and if piles are possible, try to go for some frictional pile thing. uh, just have a grid of piles created so that it can take some sort of uplift. Mr. Magaj is saying, please suggest some books for steel connection design. For steel connections, I only refer one book, which is by Professor N. Subramanian. You can refer that. Maybe you can refer to some AISC documents. Other than that, I don't refer to books usually. Please provide some idea or reference. Mr. Magaj is asking. Please provide some idea or reference to apply tuned mass damper in ETABS. I have no idea. Neither do I have reference, nor I have ever provided tuned mass damper in any of the structure I have done in ETABS. So I have no idea. Okay. So I think that's all. These were the questions that were asked. Yeah. So we have finished the questions in the Google form. We have finished the questions in the YouTube comments. So I think that's it then. Anyone having anything else? Any other question? Okay. So I think there is no other question then. So that is all for this week. Uh, yeah. Last call. Any other questions, queries, comments? Okay. So we stop. Thank you. And now we will see you in the next session. So that's all for this session of Ask AuxEn Anything. We will see you next time now. Bye bye. Have a good weekend.